something today called Pythagorean triples. When I say Pythagorean, what do you guys think? The a squared plus b squared equals c squared. Exactly, the Pythagorean theorem. Now, when I say Pythagorean triples, okay, Pythagorean triples, I am giving you three integers. What is an integer? What kind of number? A whole number. I'm giving you three integers that when I put them into a squared plus b squared equals c squared, they all fit. That's all Pythagorean triple is. Okay? So, can every set of three numbers be a Pythagorean triple? No, they cannot. Very good. They cannot. However, there are certain numbers that fit into Pythagorean triples. The most common one that I think you all have been familiar with is 3, 4, and 5. Who's heard of the 3, 4, 5 right triangle? One person. One person. So you've heard of it too. So that's when you raise your hand. Three people. Right? You got a right triangle. And it's got a right angle. It's got a height of 3, a length of 4. If I know that, how big is x? Okay, so you all have heard of it.
Yeah.
Okay.
Yeah.
3, 4, and 5 are Pythagorean triples. Okay? That's all we're going to do today. And on Monday, and on Tuesday. Now, on Thursday, we will have a test. Thursday, next week, test day. Summative test day. All right, what will the test be on? It'll be lessons 1 through 9. So the quiz that I am grading on the weekend and giving back to you on Monday and going over any questions that you might have had on said quiz, Nick and Jeff, don't make me split you up. The test, or the quiz rather, that we did on, was it Tuesday? And that we will get corrected this week and hand back on Monday. That is going to be very close in scope to what the exam will look like. So if you did well on that quiz, you're in good shape for the test. If you did not do good on that quiz, we're going to take, I believe it's Wednesday, and we're going to be able to do a retake on that quiz. All right? Yes, Andrew. Yeah. Like I said, the quiz that you did on Tuesday closely mimics what to expect on the exam. Okay? So if you feel like there's anything you need to brush up on that quiz that you did not do well on, this is the time to do it. One more question, then we need to get back to Pythagorean triples. Yeah, Ava and I actually connected yesterday about the fact that we like Justin Bieber. You're saying this is not true? You're saying this is not true? Are you saying we did not talk about Justin Bieber yesterday? Anyhow. All right. Hey, Ava and I have had enough believing for one day. All right? Let's go into this exercise. All right. Now, again, I don't have the packets because my print server is jacked up. However, Sam and Jill decide to explore a city. Both begin their walk from the same starting point. So let's, on our paper, draw a dot. Let's draw a dot. Okay? Not on the edge because we need ways to go. Okay? Sam walks. What color do we want to do Sam in? On mine. Blue. Sam's blue. And what color is Jill? Get red or green. Green. Jill. No, we're not doing gang wars. All right, Sam walks 1 block north. He goes 1 block north, 1 block east. Which way is east? 1 block east. And then 3 blocks north. See, I didn't give myself enough room. Let's do this again. So starting right here, Sam is causing me problems. 1 block north, 1 block east, 3 blocks north, 1, 2, 3, and then 3 blocks west. 1, 2, 3. Okay? So 1. Does that make sense? Yeah. Okay. Jill walks 4 blocks south. So 1, 2, 3, 4 blocks south. 1 block west. 1 block west. 1 block north. And 4 blocks east. 1, 2, 3, 4. So 2, 3, and 4. Okay. Almost looks like a swastika.
That's what I said, Mr. Cook.
No.
Mr. Cook, I said this is the start of a swastika. Ow.
Don't worry about it. I'm gonna goof. Okay, now, if all city blocks are the same length, who is the farthest distance from the starting point? So remember, my starting point is right here, right?
Yeah. Yeah.
Now, city blocks are squares, right? Which means what angle do I have? What angle is... So what's this angle going to be? That's going to be a right angle, right? And what's this angle going to be? This is going to be a right angle too, right? Now, I'm going to draw my different hypotenuses in red. Right? And right. Now, how long are the legs of Sam's triangle? What is the length of this leg? That's 3, right? 3. And how many is this leg?
4.
1, 2, 3, 4. That's 4. So, again, Jeff, how long is this red line from here to the black dot where we started? 5, right? 3, 4, 5, right? 5. Okay? Now, how long is this leg? This Jill leg? 1, 2, 3. So this is 3. How long is this leg? 1, 2, 3. Okay. How long is the red leg? Or the red hypotenuse? How do you do that? Well, 3 squared plus 3 squared equals, c squared. So 9 plus 9, right? So the square root of 18 equals c. How did I do the first one wrong? Oh, Anthony got me. He got me. No, you got me. Well, where's the triangle? Is this the side of my triangle? Or is this?
Oh, yes.
Yeah, that's the side of my triangle.
Yeah.
So it's not a 3, 4, 5, it's a 2, 4, 5.
That's what I said. Oh,
I'm sorry. Well, you talk smack all the time. It's easy not to listen to you. Bucko. Bucko? He's laying some shade. All right, so this isn't a 3. As Anthony so adroitly put it, this is really a 2. Okay? So since we're working on green, let's finish green. All right? This is the square root of 18 is C. Can somebody simplify this for me? Put it in proper radical form. This is on the test. You guys better do this. This is on the test. Who can simplify the square root of 18? Oh, you're real close, Brandon.
Well,
go ahead, Taylor.
Well,
3 root 2. 3 root 2. How'd she get that? Well, this equals the square root of 9 times the square root of 2. 9, square root of 9, Ethan? 3 times square root of 2 equals C. Okay, that is Jill's C. That's Jill's. I'll circle it in green. How about Sam's? Well, it's 2 squared plus 4 squared equals C squared. So 4 plus 16, that's square root of 20 equals C. Do it in steps, Brandon. Do it in steps. So 20 equals what times what? 5 times 4. Well, you're trying to do it in one shot. Now, can this simplify? Can this simplify? 2 and 2 comes out of, or the 4 comes out of the square root sign as a 2, right? So it's 2 times the square root of 5. All right? And that's Sam's distance. Okay. Now, here's what I want you to do. Now, here's what I want you guys to do. I want you to prove that if x is greater than 1, if x is greater than 1, then a triangle with lengths, side lengths of this, and this is a right triangle. You say so because I'm asking you to prove it, right? But let's see what this means. First of all, what do you think is the longest? If x is greater than 1, which one do you think is the longest? This guy, or this guy? Who thinks 2x is the biggest? So I got 3 for 2x. Who thinks x squared minus 1 is the biggest? Who thinks x squared minus 1 is the greatest? Nobody. How about x squared plus 1? Who thinks that's the greatest?
That's it. That's got to be.
You already voted, dude. 1, 2, 3, 4, 5, 6, 7, 8. Plus 1. X. Okay. So the x squared plus 1's have it, and you're right. X squared plus 1 will be the biggest side. So, if this is a right triangle, right triangles look like this, right? If x squared plus 1 is the longest of the expressions, where does it go? What do we call the long side? Hypotenuse, right. So this is x squared plus 1. Does it matter where I put the other two? No, it does not. So put 2x here and x squared minus 1 there. Now, I draw a lot of right triangles in my day. So now, here's what I want to do. I want to prove that 2x squared plus x squared minus 1. I hear a lot of chattering back there. I want to show this. I want to show this. So, simplify each of these terms. 2x squared becomes what? Two x squared. Not that. Not that. This. What is this? Four x squared. So this is 4x squared. How did Nick get that? This is 2x times 2x. And multiplication is commutative, yes? What does that mean, Kaya? What does it mean to be commutative? I can jumble up the order, right? So I can write 2 times x times x, yes? This part becomes x squared. Bam. 4x squared. All right. Now, I'm trying to ham this up a little bit. We talked about Ava's fixation on Justin Bieber. You're the one that brought it into class, not me. But you did. So now I gotta mess with it. All right, now everybody do this guy. How does this simplify? Brandon, how does this simplify? How do you do that? Is that right, Leah? X to the fourth plus 1. Is that right? Huh? No. 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 X squared minus 1, quantity squared. If you guys do x to the fourth minus 1 or x to the fourth plus 1, you're going to get a facepalm meme.
-2. -2.
Facepalm meme. I got to do it up here because I got glasses. But
-2.
no. This is x squared minus 1 times itself, right? Spoil. X is this times this, x to the fourth, plus the outers, minus x squared, times the inners, minus x squared, times plus less, plus 1. So how does this simplify? X to the fourth minus 2x squared plus 1. If I see this, I'm burning your test. Then I give you 0. So this becomes x to the fourth minus 2x squared plus 1. That equals Now that you've seen how not to do this and how to do it correctly, please do this correctly, everyone. I walk around and I check. Keep going. X to the fourth. Oh, for the love of Mike, Andrew. We were just over here. We were just over here. We went to a new page for it.
We're still not done.
No, we're not.
Gotta add like terms.
What you got, Nick? Hot diggity. Did that scare you, Caleb? Imagine the people on the video when they listen to that. They're gonna blow out their eardrums. I gotta be careful. You don't do, you don't learn. Math is a do thing. We got to do it. It's got to be done. My man. Extra 4. Do yourself a favor. Instead of writing that 4 just as big as the X, but moved a little bit up, shrink that baby. Move it up and shrink it. There you go. Now you know it's an exponent, okay? That's just a little housekeeping type thing, okay? That way you don't lose track of it. All right. All right. Who got
X4 plus 2x squared.
Who got that? Bam, 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 bam. All right. And now, can we see if these equal one another? Can we see if these equal one another? Oh. What can I combine over here? These guys simplify to what? A positive 2x squared, right? Hey, listen, guys. You guys are going to be lost in the test, and they're going to say, Mr. Cook, I don't get how to do this, and I'm going to laugh at you because you guys are not paying attention. I know it's mean. I know. But can I simplify this expression on the left? What can I combine? Like terms, right? The x squareds. I got plus 4 of them. I'm taking away 2 of them, which leaves me with plus 2. Yeah. So let's write it in standard order, which is highest exponent first, plus the next highest exponent, plus 1. And look, it equals the same thing that I got over here. No goody. Whenever I prove something, I bust out my Latin. I bust out my Latin. I forget the literal Latin, but it's basically means from this I get that. That's what we put at the end of proofs. Anyhow. All right, next page. Next page. Example 2. Next, we find an easy way to find Pythagorean triples using the expressions from example 1. Look at the multiplication table below. Notice that the square numbers lie on a diagonal of this table. Right? The square numbers. Here, 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 here. 1 is equal to 1 squared. 4 is equal to 9 is equal to, and so on, right? All the way down the line to 100 equals 10 squared, okay? Now, how do the numbers 1, 4, 4, and 16 at the corners of the shaded square in the table relate to the values of 15, 8, and 17. So, check this out. They want you to look at these four numbers. They want you to look at those numbers, right? And they want you to correlate them with 15. 15, 8, and 17. How do they correlate? How do I get 15 with those four numbers? Can I combine these four numbers in such a way to get 15? Jasmine. 16 minus 1. So 15 equals 16 minus 1. How do I get 8 from these numbers? Thank you. 8 equals 4 plus 4. So these guys, right? And how do I get 17 from this? 16 plus 1. Yes. Sorry. 4 plus 4. Thank you. I love you too. That is sweet. Okay? I got a microphone now. So it's not going to... So that tells me you haven't listened to one of my videos yet. Even though you said you did. All right. Now, you try one. Form a square. Form a square. Where do we want our square to be? It's got to start here. It's got to start there. Where do you want your square to be? Jordan, where do you want the square to end? Not 20. Remember, it's got to end on a perfect square number. 16. We just did 16. 25. Okay. All right, 25. So where are my four corners? 1, 5, 5, and 25. What do you think my three Pythagorean triples are going to be? 25 minus 1, 5 plus 5, and 25 plus 1. 24, 10, 26. So, here's what I want you guys to do. Plug these three numbers into your Pythagorean theorem. Which one do you think will be C? The biggest number, right? Yeah. So C of 24 squared plus 10 squared equals 26 squared. 24 squared plus 10 squared equals, and then I take the square root of that, and I get where's my square root button? There.
What?
Whoa! Whoa! Would you look at that? All right, now, try one more. It doesn't take long. Let's do 64. 64. So my four numbers are 1, 64, 8, and 8. So, what's my first one? 64 minus 1 equals 8 plus 8 equals, and 64 plus 1 equals 65. And then, last thing before we go, 63 squared plus 16 squared equals square root. Oh!
Yeah! Whoa!
All right. Listen up. There is an assignment for this. We are doing the practice set for lesson 10. I am posting this. Listen up. I'm posting lesson 10 to the Google Classroom, and it'll have the problem set. We're doing number 1, A through F, number 3, and number 7. That will be due on Wednesday. Wednesday. Have a good day.